Hi! Alright, today we are going to take a look at 7.7, which is solving trig equations. Okay, so if you look at the very top, you're going to see the chart, your normal chart, but you're going to notice that there's like some extra space here up in the top, and I'm going to explain what's going on here in a second. If you want to go ahead and fill out the middle part of your chart, I went ahead and did that, saved myself a little bit of time. Okay, today we're going to be solving equations. So we're going to use this chart again. Now, the difference is when you solve equations, we are not going to limit ourselves to those principal quadrants. So like the sine can only be in quadrants 1 and 4, and the cosine can only be in quadrants 1 and 2. When you solve equations, you want all solutions. So we are not going to limit ourselves any quadrant, any angle. Every equation we solve is actually going to have an infinite amount of solutions, and I'm going to talk about that in a second, because every single angle that has a sine value of 1/2 or whatever, we want to get every single one in the world, and that's how you solve equations. Okay, so what's going on here in the top, you know that these angles, as far as like the reference angles go, we've got 0, we got pi over 6, we got pi over 4, and so on. Okay, but again, we want every angle. So I wanted to be able, now some of you may not need this. Some of you may be able to just put your normal reference angles and you can think through what the other ones are. But again, if this is 0, if this is the column for 0, don't forget that, like especially 0, like the inverse sine of 0, this is 0, but also pi often comes into play. For the next one, this is the angle pi over 6 that has a sine value of 1/2 and a cosine value of radical 3 over 2. But again, we want all angles. So 5 pi over 6, excuse me, change the angle on this a little bit. 5 pi over 6, 7 pi over 6, and 11 pi over 6. So those are all of the angles that have a reference angle of pi over 6. Okay, so some of you may just know that, but I thought it may be helpful to actually be able to visually see them. Okay, this is pi over 4. So we've got pi over 4. Over here we have 3 pi over 4. Over here we have 1/4 past 1, so that'd be 5 pi over 4. And then this one would be 7 pi over 4. Okay, so those are all the angles that have reference angles of pi over 4. This would be pi over 3. 2 pi over 3. That's 3/3. This is 4/3. 4 pi over 3. And 5 pi over 3. This last column, this is pi over 2. But then also 3 pi over 2 if you're on the other side. Now, both of these angles work for 0. So if I need to do like the inverse cosine of 0, it would actually be both of these. Both of those would work. But if I'm doing the inverse sine of 1, it would only be pi over 2. Or if it's the inverse sine of -1, it would only be 3 pi over 2. So when you're over here on the ends, sometimes it's both of these angles and sometimes it's only one. So it kind of depends on if it's positive or negative. Okay? So let me just show you one of these examples and you'll see what we're doing here. So look at the first one. It says the cosine of x equals 1/2. Alright, so that means that x equals the inverse cosine of 1/2. So what are the angles that have cosine values of positive 1/2? So here's cosine, here's 1/2. Cosine is positive in quadrants 1 and 4. So I want these two angles, pi over 3 and 5 pi over 3. Both of them work. So x equals pi over 3. Now, I'm going to leave a space right here, and I'm going to explain that in a second. But then x could equal 5 pi over 3 as well. Okay, both of those are absolute valid solutions. Okay, so we need both of them. It's kind of like x squared equals 16. You need 4 and negative 4. You need both the solutions. Well, not only are both of these answers solutions, but if you were to add a complete revolution to pi over 3, so if I added 2 pi to pi over 3, I would get, what would that be? You're adding 6/3, so 7/3. So 7 pi over 3 is also a solution. And adding another, and adding another. So, not only is pi over 3 a solution, but any pi over 3 plus multiples of 2 pi, because that's the period for cosine. Every time you do a complete circle, you land right back where you started, and that's going to be a solution. Or 5 pi over 3 plus any multiple of 2 pi. So these are all solutions for this equation. Now, understanding that, we want to then write, the directions are going to say, then write 6 solutions. Okay, so x equals, so I've got pi over 3, that's one of my solutions. But, oops, that should be a comma. But then if I add 2 pi to that, so 7 pi over 3, I get another solution. Adding 2 pi to that, so again, I'm adding 6/3, so 13 pi over 3. Those are all solutions to this equation. Now, they want 6 solutions, so I'm going to do 3 with this, and I'm going to come over and do 3 with this. So 5 pi over 3 is a solution, but adding 6/3 to that would give you 11 pi over 3. That's another solution. Adding 6/3 to that would give you 17 pi over 3. And again, this could go forever and ever and ever. You could add, I could have you write a million. I'm not going to have you write a million. Okay, so that's the answer for this. All of those are solutions to that equation. Okay, take a look at example 2. So 3 tangent of x minus radical 3. All right, so first thing we can do is get rid of this minus radical 3. Move it to the other side. So 3 tangent of x equals, so this would be positive radical 3. Then I can divide by 3. Okay, so now you can kind of see why we were doing the inverse function and the other stuff that we've been doing. We want to kind of familiarize ourselves with solving these equations. Now I can move the tangent over. So x equals the inverse tangent of radical 3 over 3. So we want the angles that have tangent values of positive radical 3 over 3. So go to the chart. Here's radical 3 over 3. We know that tangent is positive in quadrants 1 and 3, so those are the two angles we're going to write down. Okay? Where was I? Pi over 6 and 7 pi over 6. So x equals pi over 6. Again, I'm going to leave a space for a second. And x equals 7 pi over 6. Now, tangent is also a periodic function. The tangent actually has a period of 1 pi. So actually, if I take this angle and add 1 pi k, or if I take this angle and add 1 pi k, that's actually going to get me every single other angle in the world that would work for this equation. Okay, so that's technically the right way to do it with tangent. For sine and cosine, we're going to add the 2 pi k. For tangent, we can add 1 pi k. Here's kind of a, for most of these, if you accidentally forget and put 2 pi on this, you'll still get the same angles because, let me show you. So we've got pi over 6. And then if I add pi to pi over 6, so I'm adding 6/6 to this, I'll get 7 pi over 6, which is actually this angle. And then if I add another pi over 6, I would get 13 pi over 6. And then I would get, so again, I'm just adding 6 to the numerator. I get 19 pi over 6. Then I would get 25 pi over 6. How many do I have? 1, 2, 3, 4, 5. One more. 31 pi over 6. So if you accidentally added 2 pi, what you would do is you would get this angle, and then it would jump over and give you this angle, and then this angle. And then when you added 2 pi to this one, you would get this angle and this angle. So you'll get the same answers, but technically that's the correct way to do it, by adding 1 pi. Okay? All right. Look at number 3. Why don't you try to solve number 3 as far as you can get. Okay? I'm going to do it as well at the same time. I'm just not going to talk. So if you're still solving that, you could pause this if you wanted. So here's my work. I move the radical 3 over. It's now negative. I divide it by 2. I move the cosine over. So I need the angles that have a cosine value of negative radical 3 over 2. So I'm going to use my chart, and I'm going to choose the two angles that are in quadrants 2 and 3 because that's where cosine's negative. So I got 5 pi over 6 and 7 pi over 6. I added multiples of 2 pi to both of those, and then I remember 2 pi, when you have a denominator of 6, that's like kind of like 12/6. So I just took the angle that I started with, and I added 12/6 to that, and 12/6 to that, and then I went over to the 7 pi over 6 and added 12/6 to that, and 12/6 to that. Okay? So these are my 6 solutions to this equation. There's an infinite number, but that's just 6 of them. Okay? All right, let's take a look at number 4. Okay, so now this one's got a little bit more going on. Got something being added to my variable. This time I'm using theta as a variable instead of x. Doesn't matter, alpha, x, theta, it's all the same. All right, so we need to try to solve for this. So the first thing I can do is get rid of the 2 that's multiplying. So the sine of theta minus pi over 3 equals radical 3 over 2. Now I can move the sign over, so theta minus. Now I can also drop my parentheses. Now that there's not going to be anything on the outside of my parentheses, I can drop those. So the inverse sine of radical 3 over 2. Now we need to stop. So once you get to the point where you have the inverse sine of a ratio, we need to solve this and figure out what angles, plural, work for this. So again, if you look at your chart, so sine, here's radical 3 over 2, and it was a positive radical 3 over 2. So we need the angles in quadrants 1 and 2, so pi over 3 and 2 pi over 3. Now, what we have on the left, this theta minus pi over 3, could equal both of those angles. This whole expression could equal both of those. So 0 minus pi over 3 equals pi over 3 plus 2 pi k, or theta minus pi over 3 could equal 2 pi over 3 plus 2 pi k. So both of these are not done. We haven't solved for theta yet. So on both of these, we're now going to have to add the pi over 3 to both sides. Now when you add something to both sides, you need to simplify by adding to any like common terms that you have over there, any like terms. So when I add pi over 3 to both sides, this pi over 3 that's already over here is going to get added to that pi over 3. So theta equals 2 pi over 3 plus 2 pi k. Okay, it doesn't add to this. Or, well, again, I'm adding 1/3 pi over 3 to what I already have over here, which is 2/3. So that's 3/3 now. Or pi. So that's pi plus 2 pi k. And that's all solutions of this equation. So what are some actual solutions? So from this one, I've got 2 pi over 3. And then I'm thinking of 2 as 6/3. So I'm adding 6/3 to 2/3. I'm going to get 8/3. Oops, that's a third. I'm going to add 6/3 to 8/3 and get 14/3. But then also over here, I've got pi. I'm adding 2 pi to pi, so I've got 3 pi, and then I've got 5 pi, and then it would go on forever and ever. Okay, so those are 6 possible solutions to this equation. Okay, so there's my 6 answers. All right, look at the next one. So all of these are just a little bit different from each other. So this one, again, if you don't mind, I'm going to do a couple things together. I'm going to move the 1 over. That's going to become -1. I'm going to divide by 2. So sine of 2 theta equals -1/2. So 2 theta equals the inverse sine of -1/2. So I need the two angles where sine is negative, so that's going to be quadrants 3 and 4. that have sign values of 1/2. So sine 1/2. So that's going to be 7 pi over 6 and what is that? 11 pi over 6. It was kind of sloppy. I didn't like that pen I was using at the beginning. All right, so 2 theta equals 7 pi over 6 plus 2 pi k, or 2 theta could equal 11 pi over 6 plus 2 pi k. Now, for this one, to get the theta by itself, I need to divide everything by 2. Now, for this one, we are dividing everything. When you divide, it distributes. Over here, when you add something to this side, you're just adding it to the side, and then you just combine like terms. So that's why you're not adding pi over 3 to this. You're just adding it to the like term that you have. Okay? But when you divide, you have to distribute. So I'm going to divide everything by 2. I'm going to divide 7 pi over 6 by 2. So that's now 7 pi over 12. And I'm going to add the 2, or I'm going to divide the 2 pi by 2. So that's just pi. So that's going to change those other answers that we get, because we're just going to be adding pi to this instead of 2 pi. Over here, I'm going to have 11 pi over 12 plus pi. So everything gets divided by 2. And now I need my 6 solutions. So 7 pi over 12. And now we're adding 1 pi. So we're adding 12 twelfths to that. So 7 plus 12 is 19 twelfths. Add another 12, you're going to get 31 twelfths. Now come over and do this one. So 11 pi over 12. Again, adding 12 to 11, I'm going to get 23 twelfths, and then 35 twelfths. So those are 6 solutions to this equation. Okay, so that one was a little different because of the way you had to divide by 2. The next one. Last one. So the inverse tangent of radical 3. Again, positive radical 3. You need to note that that is a positive value, so I'm going to be pulling the answers from quadrants 1 and 3, where tangent is positive. Now, it's the inverse tangent of radical 3, so I need pi over 3, I need 4 pi over 3. So, theta over 2 equals pi over 3 plus pi k. So remember, period of 1, so it's just 1 pi. Or theta over 2 equals, what did we say the other one was? We got pi over 3, we got 4 pi over 3. 4 pi over 3 plus pi k. And then for this one, since theta is being divided by 2, I need to multiply everything by 2. So if I multiply everything, again, distributing, theta equals, this will now be 2 pi over 3. This will now be 2k. 2 pi k. Or, so this is where I'm going to get, so this is an infinite number of solutions. We're going to get 3 answers from that. And then theta equals, so multiplying by 2 will give me 8 pi over 3 plus 2 pi k. So, 2 pi over 3. If I add 2 to that, so I'm adding 6/3 to this, I'll get 8/3. If I add another 6, I'll get 14/3. We'll come over here. Now, 8/3, we've already got 8/3. So I can just keep adding to this one. So what was I adding? 6/3. So 20/3, 26/3, and 32/3. Those are 6 possible solutions to that equation, and they go on and on and on forever. Okay, so that's solving equations. So take a look at the homework on that and let me know if you have any questions. Thanks.